Can I drink? Can I drink water?
Yes, yes, bete.
Yeah. Okay, I'll come.
We are on chemical bonding, right? We have discussed.
Uh, Sir, we discussed graphite and diamond, and then
Yes. So
we
can
were
you tell
going
me what are giant covalent structure? What do you mean by giant structure?
giant structure, sir.
Yes. What do you mean by the giant structures? You know that graphite is giant, right? Diamond is giant. So
So, sir, giant structures
yes.
are like structures that have covalent bonding, and all of
Hmm.
them are like joined with atom to atom.
Hmm. So you know that giant covalent means if you have covalent bonding throughout the structure, right? For example, as we have discussed last time, this is this is graphite, and you have giant structure. This is graphite throughout the structure covalent bonding. So giant molecular structures, yet or giant covalent structures have high melting point. High melting point. Why they have high melting point?
Because they have
Because
like
they
very
have
strong intermolecular forces.
very good, very good. Because they have very strong intermolecular structure and bonding, right?
Yes, sir.
So, can you tell me which one has high melting point? Diamond or graphite?
Sir, diamond.
Diamond. Can you tell me why?
Sir, it has it's the hardest known material we've known.
You know that in
Sir,
diamond
sir, because sir, I know, sir, because they don't have any
Very
the
good.
intermolecular,
Hmm.
they don't have layers. Uh, they don't have intermolecular force of attraction.
Because you know that in graphite we have weak intermolecular force of attraction, right?
Yes.
Which which is known as van der Waal, right? But in diamond we have covalent bonding throughout the structure.
Yeah.
So that's why they have different boiling point, different melting points, right? So next, which one has free electrons? Diamond or graphite?
Uh, Graphite, sir.
Graphite. Why graphite has free electron?
Sir, because each graphite in graphite structure, each atom can form four bonds because it's a carbon, and carbon has four
Very good,
valence
very
electrons.
good.
But then it forms only three bonds. So the
Hmm.
remaining electron, it's a free electron, so it can conduct electricity.
Very, very good. Very good. So in graphite we have three bonds, but in diamond we have four bonds. So four bonds means there's no free electron, but in graphite you can see that we have three bonds, right? That's why they have free electron. So graphite has free electron. That's why it conduct electricity. Okay, next is, which one is soluble? Graphite is soluble or diamond is soluble, or both are insoluble?
Sir, both are insoluble.
Both are insoluble. Okay, very good. So, do you know what is sublimation?
Yes, sir. From solid, the conversion from solid to gas.
Exactly. So, can you tell me which one sublime? Graphite or diamond? Which one sublime?
Graphite, sir.
Graphite? No. Both. Both can be sublime, right? Diamond and graphite, both sublime, right?
Okay, sir. But why?
Allah make such a way that whenever you provide the heat, they directly convert into gas without
Oh,
being
okay, sir.
converted into liquid.
Okay,
Now,
sir.
third part is silicon 4 oxide, silicon dioxide, right? So you know that silicon dioxide is also a giant molecule. So first point is, it is a giant, it is a giant covalent structure. It has giant, it has giant covalent structure. It has a, it has a giant covalent structure. Can you tell me how many bonds are there? Can you tell me silicon atom covalently bonded with how many oxygens?
Four, sir.
Yes, 4. So next point is, each silicon atom is covalently covalently bonded with 4 oxygen atoms. Oxygen atoms. So 4 means tetrahedral. Now can you tell me how many bonds are there between one oxygen and silicon? Yes.
Uh,
Can you tell me how many bonds are there between one oxygen and silicon?
Two, sir.
2. Very good. Each oxygen atom, each oxygen atom is covalently bonded with two silicon atoms. Silicon atoms. So you can you find any free electron in silicon?
Not in silicon, but I think in oxygen, right?
Yes, but we are talking about
Yeah, yeah, there
silicon.
is. There is.
Okay, so there is no free electron on silicon. So there is no mobile electron.
Sir, so it means that silicon has eight atoms, eight electrons.
Uh, you know that it follow octet. That's why around the silicon we have eight electrons. But you know that group silicon belong to group 44. That's why it has 4 electrons. You can count 1, 2, 3, 4. Silicon has 4 valence electron.
Okay.
So all electrons are utilized to make covalent bond. So there are no free electron.
Okay, sir.
There are no mobile electrons, no free electron. Number 5, throughout the structure, silicon 4 oxide, throughout the structure silicon 4 oxide has covalent bonding. Throughout the structure silicon 4 oxide has covalent bonding. That's why it is strong, hard, and has high melting point. High melting point. It is not a good conductor. Why it is not a good conductor?
Because there are no free electrons.
Very good. It is not a good conductor. As we have discussed, there is no free electron. Now, this is all about the silicon 4 oxide, right? Now, next, this is chemical bonding 2.6, right? So we have discussed the giant structure. Now, relate the structure and bonding of graphite and diamond to their uses, limitation, to graphite as a lubricant and as an electrode, diamond is cutting tools. Then write the similarity and properties between diamond and silicon oxide related to their structure. Now, point number 2, graphite and diamond. So uses of diamond, and
Sir,
graphite. Yes.
said we wrote that like in diamond, the uses of diamond are like in jewelry, in duty sparkly
Mm-hmm.
appearance, and like in drill bits and tooling equipment because it is very hard and strong.
Very good. So use of graphite as a lubricant. So next is graphite as a lubricant and electrode. So second point is graphite as a lubricant and as an electrode. Now say something about the lubricant. Why graphite is used as lubricant? Yes,
Sir, it is because it is slippery.
yes,
Sir, it is because it's slippery. As the force of attraction between each layer is weak, as it uses van
exactly.
der Waals.
Because exactly they have weak van der Waal, so they graphite layers can be slide over each other. So as you told me that they graphite is slippery, so it is used as lubricant. And why electrode?
Sir,
Yes.
what is electrode?
What is electrode? Very good question. So first move to this point that graphite is an as a lubricant, right? So what is lubricant? Yes,
Sir, lubricant is like a substance which reduces friction usually.
which reduce the friction, right? Okay. And what is lubricant?
Sir, it's a liquid.
Lubricant is anything, any chemical which reduces the friction, any material which reduces force of friction, force of friction. Force of friction. So why graphite is used as lubricant?
Because graphite is slippery, sir, and then
Exactly,
and its layers can
exactly,
separate.
exactly, exactly. Graphite has slippery nature. Slippery nature. Next, the layers in graphite can slide over, each other because why? Because they have weak van der Waal forces. Because the forces between them are weak. The layer in graphite can slide over each other because the forces between them are weak. So they can move easily from one place to another, making a graphite good conductor of electricity. Are you getting my point or not?
Yes, sir.
Yes, sir.
So always remember that graphite has slippery nature. Can you tell me why graphite is a lubricant and diamond is not?
Sir, because the forces of attraction between them, the intermolecular force of attraction is in diamond is stronger as there's no weak bond at all. It's all made up of covalent bond.
Okay. So question is that why is graphite a lubricant and diamond is not? Yes.
So it's graphite is a lubricant because the layers in graphite slide over each other as the forces between them are weak. But in diamond, the forces between the layers are not weak.
Mhm. So graphite, the answer is graphite is soft, non-volatile, soft, non-volatile, that's why it is used as lubricant at high temperature. At high temperature. While while diamond is very hard, is very hard substance, and throughout the structure, it has covalent bonding and difficult to slide diamond layers. Are you getting my point or not?
Yes, sir.
Now, what is electrode? Right? Now, electrode. What is electrode? Yes, do you know what is electrode?
No, sir.
Okay, because it is a part of electrochemistry or redox reaction, right? So simple definition of electrode, you know that in pencil cell, when you open it, right? In the pencil cell, you have a black rod in it. Have you ever seen this rod?
No, sir.
Yes. Do you have a pencil cell?
Pencil or pencil cell? What, sir?
Pencil cell, which is used to run uh, wall clock.
Oh, yeah, yeah, yes.
So electrode, inside the electrode, we have this electrode. This is called electrode.
Sir.
Yes.
So we can say that graphite is used as an electrode because it conducts electricity.
Yes, exactly. So electrode is the place where electron transfer occurs. So electrode is the place. Yes, electrode is the place where electron transfer occurs. Electron transfer occur. Are you listening to my voice?
Yes, sir.
Now, can anyone tell me why graphite is used as electrode? Yes.
Sir, graphite is used as an electrode because it has a delocalized electron. It is free to move, so it means that graphite is a good conductor. So that's why
Very
it
good.
is.
Very, very good. So next point is graphite is used as electrode material because it is a good conductor. Because it is a good conductor of electricity. Good conductor of electricity. Why it is a good conductor of electricity? It has free electron. It has free electron. And it is stable at high temperature. It is stable at high temperature. That's why it is used as an electrode, as an electrode. Are you getting my point or not?
Yes, sir.
Yes, sir.
So next is, yes, diamond is cutting tool, right? Yes. Can you tell me why diamond is used as cutting tool?
Sir, diamond is used as a cutting tool because it's the hardest known metal. So it is really it is a hard and strong substance. So we can cut many things through it.
Very good. Because you know that it is very hard. That's why diamond is used as cutting tools. Diamond is used as cutting tools. Can graphite is used as cutting tool?
No, sir, because yeah, its layers are its graphite is soft and its layers are weak.
Okay. So question is, why is diamond used in cutting tools? Because they are considered to be the hardest element and are able to cut through hard material, through hard materials. Do you have any, do you have more answer?
Sir, because the layers are not made up of weak van der Waal, but throughout the structure there's covalent bonding, which is strong.
Mm, very good. So the hardness of diamond is due to its crystal structure. You can say that. Another point is mm, diamond atom. Diamond, or you can say that atoms in diamond. Atoms in diamond. Atoms in diamond are covalently bonded. Covalently bonded. That's why it is very hard. That's why it is very hard. Any idea? Do you have so no now you can you tell me if you want to cut diamond, which material is used to cut the diamond?
Sir, diamond.
Sorry?
Sir, to cut diamond, yeah.
Yes, if you want to cut diamond,
Sir,
which material is used to cut it?
sir, to cut diamond, you have to use diamond.
Exactly. So diamond cuts diamond. Diamonds cut diamond. Diamond cut diamond. Next is describe the similarity properties between diamond and silicon dioxide related to their structure, right? So first compare diamond and graphite. Describe differences in structure and bonding between diamond and graphite. Diamond and graphite. Diamond and graphite. Now make 3 columns. Here diamond. Here we have graphite. Yes. First is number of carbon atom bonded to each carbon atom. Yes. Now
Sir,
number
in
of,
that,
sorry,
nothing, sir.
number of carbon atoms covalently bonded to each carbon atom. You know that carbon is bonded with 4 carbon in diamond and 3 in
3
graphite,
in graphite. Yeah.
right? So next is bonding. Next is bonding. Covalent or van der Waal in diamond?
Sir, in diamond, it's covalent.
Covalent, all covalent. Throughout. Throughout covalent. So covalent throughout. Throughout covalent. While in graphite,
There's 2. It's covalent and van der Waal both.
very good. Covalent plus van der Waal. Very good. Number 3, hardness. Yes. Which one is hardest?
Graphite.
Graphite is hardest, right? So diamond is hard. Why hard?
Sir, diamond is hard because it's only made up of covalent bonding
Be-
and not van
Exactly,
der
because
Waal
all bonds are
throughout
covalent.
this.
Very good. Very good. And graphite is hard or soft?
Sir, graphite is soft.
Soft. Why soft?
Because it has layers, and the
Because
the,
it
for, the forces
has,
and the forces between each layer is weak.
very good, because it has weak van der Waal. Because it has weak van der Waal. And each layer can slide over each other. Each layer can slide over each other. Now next is conductivity. Conductivity. Yes, diamond is used as conductor or not?
Sir, diamond is not used as a conductor. It is
Very
because
good,
it doesn't have
non-conductor.
any. Yes, it is
Very
because
good.
it
Why
doesn't have any free
non-conductor?
electrons. Sir, it doesn't have
Exactly,
any free
because
electrons.
because it has no free electron. Because it has no free electron. And what about graphite?
Sir, graphite is a conductor because it has one delocalized free electron.
Exactly, because it has mobile electron between layers. Between layers.
Sir,
Yes.
can there be any alternate word for mobile?
Just a minute. Yes. Can you repeat your question?
Sir, can there be any other alternate word for mobile?
Mobile means free to move,
Okay, so we can say it has
because
free electrons.
yes, you can free moving, moving. Mobile means
Okay,
moving. In chemistry, mobile means free to move. Now, next heading is mobile electron. So, which one has mobile electron?
Graphite, sir.
None.
And diamond has
But
none.
one electron. One electron. Next is arrangement of atoms. Arrangement of atoms. Diamond is tetrahedral. While it is in layers. In layers. Last is uses. Uses. Diamond is used as cutting tool. While graphite is used as lubricant and conductor.
as electrode here.
Or you can say that electrode. Electrode and conductor both are same thing. Electrode. Electrode. Yes, next topic is comparison between silicon and I think
And diamond.
yes. Describe the similarity in properties of diamond and silicon oxide related to their structure. Yes. Yes. This is our last topic, right? Last topic of this chapter. Describe the similarity in properties between diamond and silicon dioxide. Okay. Describe the similarity and properties between diamond and silicon. Yes. Any idea?
Sir, first,
Sir, sir, is it silicon oxide or silicon dioxide?
Both are same thing. Silicon 4 oxide, silicon dioxide, silicon oxide.
Okay. So, sir, one similarity between silicon oxide and diamond can be that there are no free electrons uh, in them between the bonds.
Okay, and
they have covalent bonding throughout the structure.
they have exactly. They have covalent bonding.
Sir, and also each atom is covalently bonded with four oxygen atoms.
Mm,
Is it
okay,
correct?
both are having same.
And they're also not good conductors.
Both are non-conductor, correct? Both are non-conductor. Okay, now let's start similarity. So first point, second point. Sorry, here we have diamond. Here we have silicon 4 oxide. Now first point is structure. First point is structure. So diamond is tetrahedral structure. Tetrahedral. Similarly, silicon 4 oxide is tetrahedral. Point number 2. Number of bonded carbon. Each carbon atom joined with 4 more carbon atom. While silicon dioxide each silicon is attached with 4 oxygen. Am I right?
Yes.
And each oxygen is bonded with 2 silicon atoms. So this is bonding. Bonding. Next is
Sir, so each carbon atom is joined with 4 more carbon atoms in diamond, yeah?
in diamond,
Okay.
just like this: carbon, 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 carbon. Why in silicon? Silicon, oxygen, 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 and this silicon.
Sir, so what's the name, like the name for diamond?
You know that tetra means 4. So diamond is bonded with 4. That's why its structure is tetra. Similarly, silicon is bonded with 4. That's why it is tetra. Are you getting my point or not?
Okay, sir.
Now next is giant. Giant. So both are giant molecular. Giant molecular. Giant molecular structure. Giant molecular structure. Now conductivity. Next is conductivity.
Sir, both of them do not conduct
Why?
because they don't have any free mobile electron.
Exactly. Neither in silicon, neither in nor in diamond, right? So
Yes, sir.
next is conductivity. 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 Cannot conduct. Cannot conduct electricity because no free electron. Same answer for silicon 4 oxide. Now next is hardness. Next is hardness. Hardness. Which one is hardest?
Sir, diamond.
Diamond. Both are hardest. Hardest. Both are hardest. It is
But diamond is
hard.
strong. But diamond is harder, right, sir?
Yes, diamond is also the hardest, but silicon is also hard, right? It is hard. A lot of energy is required. A lot of energy a lot of energy is required to break the covalent bond. Covalent bond. Same answer. Same answer. Now tell me melting and boiling point. Yes.
Sir, so you can say silicon and diamond are both the hardest. It's not like one is harder than the other.
So high melting and boiling point because of the strong covalent bonding, right?
Yes, sir.
Boiling points are high. Melting and boiling points are high. The reason is same. Throughout the structure, covalent bonding. Now this is 2.6. Wait, just a minute. Okay, we have discussed 2.6, right? Now we are moving. This is lecture number 10, right? Lecture 10. Okay. Now 2.7. Now this is last one, 2.7, metallic bonding. And then we will start yes, describe metallic bonding. Yes, do you know anything about the metallic bonding? Yes.
Yes, sir.
Yes. What is metallic bonding? Can you tell me anything about the metallic bonding? Do you know anything about it?
No, sir.
Okay.
I knew about ionic and covalent, but not metallic.
Okay, okay. So you know that metals have special type of bonding known as metallic bonding, right? So all metals have special kind of bonding known as metallic bonding. So make the heading metallic bonding. Yes.
So is this for like metal and for the bonding between metal and metal?
In the metal, not metal with the metal, in the metal.
Okay, sir.
Metallic bonding. So metallic bonding is the bonding within the metal. Bonding between the metal, right? Can you give me some example of metal?
Sir, iron,
Iron and
magnesium,
magnesium, okay, and
sir, silver.
silver. Silver is also metal, okay. Do you have a periodic table?
Yes, sir.
Yes, sir.
Now look at the periodic table and read the first row of first column. First column.
Uh, that it says like it says hydrogen, and then lithium,
Yes,
sodium, potassium.
sodium. Sodium is
Uh,
metal.
yes, sir, sodium is metal.
Lithium is also metal.
Then
And
potassium,
potassium is metal.
rubidium,
Rubidium is metal.
and cesium.
Cesium. So lithium,
Yeah,
sodium, potassium, rubidium, cesium, and francium.
yeah.
All are metals. All are metals. So they have metallic bonding. Are you getting my point or not?
Sir, can you repeat again?
I told you that first column of periodic table is known as group 1. So they all have metallic bonding.
Oh, okay, sir. So like the first group.
Yes, first group. Yes. Now read the group 2. Now read group 2.
Sir, for group 2, it's beryllium, magnesium, calcium,
Mm.
and then strontium, barium, and radium.
Exactly. So all these all are metals. So they have metallic bonding. So it means group 1, group 2, right? Group 1, group 2, both have metallic bonding. Are you getting my point or not?
Yes, sir.
Now look at the periodic table and find more metals, right? Now try to find transition metal which start from scandium. They are
Uh,
called
Sir,
transition metals. Yes.
so zinc, copper, nickel, cobalt, iron.
Yes, yes. These all are transition metals. They all have metallic bonding. Are you getting my point or not?
Sir, does aluminum also count as a transition metal?
Sorry, which metal?
Aluminum, sir.
Aluminum is metal. It is not a transition metal. So it is metal and it has metallic bonding. Now let's start. Let's start metals, right? Now look at,
Sir, so
yes,
basically, all metals have metallic bonding.
all metals have metallic bonding. and the metallic bonding is very, very strong. That's why all metals have high melting and boiling point. Now, look at this structure, right? It has positive charge, right? So you can see that metals have these signs. Metals have these signs. This is the layer of metals, right? This is metal, right?
Yes, sir.
All are metals. This is metal. This is metal layer. This is metal layer. All are positive ions, right? All are metal ions. All are metal ion. So, for example, if it is sodium, so all are sodium plus. If it is calcium, all are calcium plus 2. Are you getting my point or not?
Yes.
Yes, sir. So the
Now,
plus means that it's an ion.
yes, these are cations, right?
Yeah,
Why
cation.
positive ion is there? Why positive ion is there? Because electrons are slightly move away from the metal, right? For example, you have sodium, so electron is removed. So all are electrons.
Like,
This is electron.
where did the electron get in, sir?
Beta electrons are removed from metals, right? You know that electron has uh, metals have delocalized electron, right? So it means they can delocalize from one place to another place, right? So it is the tendency of all metals. They have valence electron, which are very mobile.
Okay, sir. Okay.
These are the electrons. Electrons, 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 electron. All are delocalized electron. So these electrons are removed from the metal. These are known as delocalized electron. These all electrons are delocalized. For example, if you have sodium, 1 electron is removed. For calcium, 2 electrons are removed. So as the number of delocalized electron increases, metallic bond strength increases. again is that it is attraction between the oppositely charged ion.
So it
That's
is
why it is known as
electrostatic
electrostatic
force
force
of
of
attraction.
attraction. Very good. Very good. That's why it is called electrostatic force of attraction. So you can see that electrons are removed and positive charges are developed on the metal nuclei. So now look at this is metal surface, right? In your home you have iron, right? So in the on the surface of iron we have delocalized electron, right? For example, it is sodium. So one electron is, you know that sodium has one valence electron. So these are electrons from valence shell of metal atoms. These electrons are delocalized.
Yes, sir.
So electrons are delocalized. Electrons are delocalized. They are free to move. Now these are positively charged metal ions. Metals ion. Are you getting my point or not?
Yes, sir.
This is called lattice structure. This is called lattice, metallic lattice structure. Metallic lattice structure.
Sir, this is why like usually metals are able to conduct electricity because they have delocalized
Yes,
electrons
yes,
into
exactly.
them.
Because they have free electrons. It is only the property of metals, right? That they
Yes.
can delocalize valence electron. So this is a diagram showing metallic lattice structure with delocalized electron. So do you have any question? Yes.
Yes, sir.
Do you have any question?
No, sir.
Okay. So inshallah, we will start lecture number 11 of metallic bonding, right? In the next class, right? Lecture number 11, metallic bonding. Okay. Any question?
No, sir. No questions.
Okay, okay. Then Allah Hafiz.
Thank you, sir. Allah Hafiz.
Hafiz.
Thank you, sir. Allah Hafiz.
Allah Hafiz, beta.